Hi, I'm Mr. Richmond, and this is your Unit 12.3 lesson summary. Unit 12.3 will be on bisecting angles and translating angles and just starting to work in general with angles in geometry. So I'm going to hop right into a couple examples with this. First, let me talk about an angle for a quick moment. An angle is formed when you have a ray. And to review what a ray is a single point extending out in one direction forever. So it's a point extending out with a line at the end. You have an angle when you connect two rays together stemming off from the same point. So I would call this angle X. Okay? Angles are measured in degrees. You can measure them using a protractor. Put your protractor on there, you line the center, extend it out, and it measures in degrees. Hopefully we're fairly familiar with that. A 90-degree angle makes an L shape, makes a perfect square in the corner. So anything below 90 degrees is an acute angle. So this here would be an acute angle. If it extends out past that, it's an obtuse angle. We'll probably review that a little bit more later. But one of the first skills I want to be able to do is translate an angle, be able to move one. And since an angle really is just comprised of two segments or two lines, I can translate it the same way I was translating segments in the previous section, by translating each individual point on the angle. So to translate angle ABC here 7 units right, I just take each point and move it 7 units to the right. Before I do that, let me write the coordinates in here for ABC, the original image, because I know with the video and all, it's probably a little tough to see exactly what these coordinates are, so that way you can have them correctly. Coordinate A should be -2, 6. Just write that in. Coordinate B should be -1, -2, -3, -4, -5, -6. 2, and coordinate C should be -2, 2. So these are the original coordinates I'm going to work off of. What I'm going to do is translate this angle 7 units to the right to start. So I'm going to take A and I'm going to move it 7 units to the right. 1, 2, 3, 4, 5, 6, 7. And since it's a new image, I'm going to call it A prime. And I'll do the same with B and C. 1, 2, 3, 4, 5, 6, 7. Makes that B prime. And C, 1, 2, 3, 4, 5, 6, and 7. Makes that C prime. And now I can connect those segments and draw my translated angle. Remember, when you do a translation, you are not changing the shape, the rotation, the reflection, or the size of it. It's exactly the same size, it's just shifting left, right, up, or down. I'm going to write those new coordinates. Now, when I go to write the coordinates, I want to illustrate how translations work again and what they affect. When I translate something horizontally, I'm only changing its horizontal value, so I'm changing its x values only. So I should see these coordinates only being changed in the x position. How are they changing? Well, I'm moving 7 units to the right, that's towards positive numbers, so I should be adding 7 to each of these. -2 plus 7 is 5, so my new A coordinate should be 5, 6. -6 plus 7 is 1. So my new B coordinate should be 1, 2. Adding 7 to C is 5, 2. And I'm going to just verify that with the graph. 1, 2 for B image, correct. 5, 2 for C image, correct. 5, 6 for A image, correct. So you can get the new coordinates from a translation by just understanding how the translations affect the coordinates. Horizontal translation, a change in X, add or subtract to X accordingly. Now let's take that image and translate it a second time to make a second image. We're going to translate it down 6. So I can now translate each of these down 6 and redraw the shape, or I can just translate the coordinates and then plot them. I'm going to do it the other way this time. I'm going to do the coordinates first. A translation down should affect our y coordinate because y controls up and down. Y is vertical. So down would be towards negative numbers, so I'm going to subtract the 6 to each of these. So my A coordinate should go down by 6, making the new image A double prime, 5, 0. 1, 2 minus 6 is -4, and 5, -4. And so I can get my coordinates before I do it and then just plot those coordinates. A should now be at 5, 0, 1, 2, 3, 4, 5. So there's my new A double prime. Down 5, so it would be 1, -4. There's my B double prime. And my C is 5, -4, C double prime, connect them in the same way, and draw my angle, and I've now translated that angle twice. So hopefully that helps review translating in general, but also how to translate an angle. Now, let's talk about angle bisectors. So we already learned in the previous lesson what a bisector is. A bisector splits something into 2 equal parts. Since we're dealing with an angle bisector, what we'll be trying to do is split this angle directly down the middle so that it's in 2 congruent halves. To do that, I will need my compass. So I'm going to take my compass and I'm going to make an arc. And I'm going to stem my arc off of the central angle X, and I'm just going to make any arc I want. It just has to be big enough that it goes through both rays. Simple as that. Okay? Now, you should have an intersection point for the 2 rays. I'm going to call those Y and Z. So the first arc is just a general arc. It can be any size. You just want to make sure it's big enough to go through both rays. Now I need to set my compass to an exact size. It needs to be the exact distance between the 2 intersection points you just found. So I'm setting my compass to that distance. I'm going to freeze it in that position. I don't want to lose that. So now it's the distance of YZ. And my second bisector is going to split out here somewhere. So I'm now going to make 2 arcs stemming off of the 2 coordinates I just found. So I'm going to place it on my Z now and just make a general arc out in that zone. And I'm going to do the same now off of Y, making a general arc off of each coordinate. Now I have an intersection for those 2 arcs, which I'm going to call M. And all I have to do now is take my straight edge and connect my angle from the center here, X, out to that intersection point. And you now have your angle bisector. If you're doing this at home, I suggest drawing your own angle, getting out a protractor and actually measuring that angle. See how many degrees it is. Then perform these constructions and measure your 2 new angles. If you did it right, these should equal half the original. Okay, you want to make sure you do that fairly accurately. So that's how you construct an angle bisector. It's very similar to how we did a segment bisector. General arc, connecting dots, set to the correct length between the 2 points, and then make 2 arcs of the same length off of that. And that intersection point lies on your angle bisector. So some quick rules that we need to know about that. If that's an angle bisector, let's assume that angle YXZ, our original angle, was a full 70 degrees. Okay, if it's 70 degrees, my expectation for a bisector is that it splits in half, then it should be splitting both of these into half that size. So I would expect the measure of angle Y, X, M, Y to X to M to be 35 degrees, which also means from M to X to Z, M to X to Z, should also be half of that at 35 degrees. Now, there are a couple problems that pop up sometimes that ask you to, let's say, double an angle, or make an angle twice as big, or make an angle 1/4 its size. So if you ask me to make this angle 1/4 of its original size, all I have to do is, I've already split it in half once, I have a new angle MXZ that's half of it, is just continue these steps one more time and split this angle again. So if I wanted to do that, I could just, again, make a general arc. I have 2 intersection points here. I'm going to set it to that length. Make 2 general arcs off that section. And find the intersection point of those 2 arcs. The only difficult part really is when you're doing these angles that are 1/4 the original, or twice or 4 times as big, is you're going to have more arcs and you kind of got to keep track of things. Might not be a bad idea to erase the older arcs as you do this. And so if I bisect this angle here, now I have another angle that's now half of the half, which is 1/4. Okay, and you can do the same thing in reverse to make bigger angles as well. Hopefully this helps you. Good luck. Make sure you practice those constructions. Thank you.